In this problem, it tells us that the test statistic of z equals 2.05 is obtained when testing the claim that p is greater than 0.1. So first we want to identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. And since the claim is that p is greater than 0.1, that means that we're looking at a right-tail test because we're just looking at greater than. If it were less than, then it would be a left-tail test. If it were not equal to, then that would be a two-tail test. All right, next we have to find the p-value. So let's take a look at our normal distribution. And I can label my horizontal axis. And I want to find the p-value, and my test statistic is 2.05. So here's my test statistic, and the p-value is going to be the area in the tail past that test statistic. So we can see it's not going to be a very large value. And how do we find this on the calculator? I'm going to find normal CDF. And my left-hand boundary is going to be the 2.05. The right-hand boundary, there really isn't a boundary. That's positive infinity. So I'm going to type in 1E99 for that. And then 0, 1 if you need to put in the mean and standard deviation. And when we calculate this, we get 0.0202. So now if we're using a significance level of alpha equals 0.05, should we reject the null hypothesis or fail to reject? So I'm going to take alpha, 0.05, compare that to our p-value, 0.0202, and since alpha is greater than p, we are going to fail to reject. I just said that backwards. We are going to reject the null hypothesis because what we're saying is the p-value is very small. It's falling out here into the tail. So we're going to reject the null hypothesis. And that is the end of that problem.